Circle.
Okay.
With love.
The first thing that we talked about in Chapter 5 were parallelograms. So when you see a picture of a parallelogram, you need to be able to identify all the properties and all the things that you know about them.
Oh, that was cool.
All right, so I want y'all on your own paper to draw this as best you can. And we're going to remind ourselves what we know. I want you to put it in tick marks on your picture and in words. But this is a parallelogram. So next to your picture, label it as such.
We were told that this is a parallelogram.
Yes, I am telling you it's a parallelogram.
What if ours isn't a parallelogram?
Patrick, it doesn't matter.
Oh, Josh is like Patrick's dad.
Okay, so we're going to talk about all the things we know about parallelograms. The first thing we know is that opposite sides are parallel and what?
Congruent.
All right, so let's mark that. Okay. What do we know about the opposite angles?
Yes.
They are congruent. Okay? I'm not going to mark that on my picture because I'm going to mark something else soon. What do we know about the diagonals of a parallelogram?
They bisect.
They bisect each other. Okay? So that means that this equals this, and that this equals this. Right? Okay. Now, those were the theorems and the properties and everything that were listed out. Now, based on other stuff that we know, using parallel lines and imagining that these two double-marked parallel lines are the ones that we're looking at, cut by this triple-marked transversal, what do we know about alternate interior angles? Those are equal to each other. Which means that for the same reason, so are these.
See.
And do we have two more pairs of congruent angles in there?
Yes.
See.
Okay, I'm running out of colors now. This angle is equal to this angle, and this angle is equal to this one.
It's a lot of stuff.
All right, it is a lot of stuff, and you may not have to label all that information, but you need to know what you know. Well, yeah, but we're not going to label that.
Miss Allen,
Yes.
don't the angles that are right next to each other on the parallelogram, are they equal to? Like the 2 line and the 3 line? Are they equal?
7.
No, they're not equal to each other.
Why not?
They're not bisected.
Why?
Only in a rhombus are those angles bisected. Right now, we're just talking about a parallelogram. Okay. Sam? Yes, we are recording. Okay.
I did even the vertex angles.
Very good. But these are the things that we know about a parallelogram. Now remember that there were ways that we can prove that a four-sided figure is a parallelogram, and it's taking all this information and going backwards plus a few more. If both pairs of opposite sides are congruent, it's a parallelogram. Do y'all remember that? If only one pair of opposite sides is both congruent and parallel, then it's a parallelogram. If the diagonals bisect each other,
Parallelogram.
it's a parallelogram. What about if one pair of opposite angles is congruent? No. But if both pairs of opposite angles are congruent, then it's a parallelogram. All right, so you need to be able to look at those types of pictures and that information and decide tomorrow, is this a parallelogram or not? So you need to go back over those little things, and that was from section 5-2. All right, now we also talked about theorems involving parallel lines. Now we already know all of our stuff about corresponding angles, alternate interior angles, and all that other stuff.
Oh, it's the 3 line.
We'll just draw 4 lines. Okay? Remember we said if you have parallel lines, all these are parallel and you've got transversals going through them, if one of these transversals has been cut off into equal segments, then what do we know about that other one?
It's gonna make seconds.
Those are also equal segments.
They're not necessarily equal to each other.
They're not necessarily equal from one transversal to the next, but the transversal itself is cut into 3 equal segments. All right? Now this means that if we have a measure, let's say for this segment here, we can find either one of these individually. What would they each be?
Wait, Miss Allen, what if those parallel lines are like different spaces apart?
Then they're not going to do this.
How do we know?
Patrick, this works.
It will show you. They will give you, like, see these red tick marks? Those will be given.
Okay.
You will have to conclude the green ones. Will Keller. Yes, everyone listening, that is Will Keller that is causing such a commotion in the background. Mrs. Keller, it is your son Will who is causing such a commotion
She
in the
doesn't watch
background.
the.
Hi, Miss Keller. Son, you know his teachers always refer to the people making their tests as they when they really make their test.
Not always. Okay.
You just did, and Mr. Grover did last week. So
We could also figure out if I asked you what the length of these two things together were.
8.
It's 8. We could figure out what the whole thing put together is.
6,
12.
But by simply knowing the relationship between those segments, we can figure those things out. We can also set up equations to find our missing pieces. Watch this. If we know that this is true, and I tell you that this has a value of 2x, and this has a value of
58x.
4. Two x equals 3x minus.
and I asked you to solve for x,
They equal to each other.
So
X
negative.
is equal to 2.
Yeah.
the first thing I look is what's the relationship between those line segments? They're equal to each other. So I set them equal. Now I could ask you several questions. Here I find that x is equal to 2. I could say, what's x?
2.
X is 2. I could say, suppose this was AB, CD. I could say, what is the length of AB?
2.
No.
Oh, 2x.
4.
AB is 4. It's 2 times 2.
How is it 4?
I could ask you,
Wait, but how's it?
because if x has a value of 2, and the length of AB is 2 times x,
That's 4.
Oh, right.
then it's 4. Shh. I could now say, what's the length of AD?
12.
This is 4 plus 4 plus 4. It's 12. All right? But those are all the types of questions that can be asked. So it's very important that tomorrow when you're taking your test, when you're dealing with these types of problems, don't just get to X and stop. If it says find X, then you can stop. But answer the question that I'm asking you.
Will they ever do angles with them?
I mean, we could.
Know that they're
Yeah, I know you
Alternate
could,
interior, vertical, but
same
no.
side.
No, I'm using it for
Okay.
segments. Okay, let's talk about the properties we learned about triangles and the medians in a triangle.
They have 3 sides.
Wow.
I don't want to write triangle.
So you want to throw a left triangle?
I don't want an isosceles triangle.
Throw on the left.
Pull it down.